All right. Good afternoon, everyone. My name is Zinhle Sanda. I'm from CHPC, and today I'll be your chair for this session. Our first speaker will be Dr. Kobus Herbst. Dr. Kobus Herbst is a director of CEPRIN, which is hosted by the South African Medical Research Council. He is a faculty member, the Director Population Science at the African Health Research Institute, and the Principal Investigator of the Population Intervention Program. So his passion is information and how information management contributes to the scientific process. Welcome, Dr. Kobus Herbst. Over to you.
Thank you, Zinhle, for the kind introduction, and thank you for the opportunity to share CEPRIN's experience with using the Center for High Performance Infrastructure, specifically the cloud platform, to process our longitudinal population data. In my presentation today, I will briefly explain what the South African Population Research Infrastructure Network, CEPRIN, is, I see my screen share has now been replaced, sorry. Thank you. In my presentation today, I will briefly explain what the South African Population Research Infrastructure Network, CEPRIN, is, what longitudinal population data are and what it's used for. I will then move on to discuss why we need the capabilities of CHPC to process this data and give a high-level overview of how the data is processed. I will then summarize our experience in using the infrastructure and conclude with some next steps. CEPRIN is a major long-term investment in a national research infrastructure funded by the Department of Science and Innovation and hosted by the South African Medical Research Council. We currently have 4 nodes, each with a surveillance population of around 100,000 individuals. The 3 rural nodes have been in operation for more than 20 years. And the data I will be talking about are from these nodes. The urban node in Gauteng started this year and is still busy with their baseline enumeration. The node in Cape Town will start next year, and the nodes in eThekwini and Eastern Cape will follow after that. These nodes all follow a common research protocol based on enumerating the complete population in a defined geographic area and geolocating each homestead where these households live. This baseline population is then followed over time by contacting each household 3 times per year and recording every birth and in-migration. Also, new households not enumerated during the baseline census. Outflows from the population through deaths and out-migrations are recorded as well. This results in a detailed longitudinal database of the population. In the case of the 3 established nodes, almost 570,000 individuals have identified, representing 4.5 million person years of follow-up. In addition, nested studies in these population records biomeasures, for example, height, weight, blood pressure, or genomic data to record a detailed population phenotype. This approach also lends itself to record linkage to administrative records such as medical, educational, and social support records. CEPRIN nodes represent an uniquely powerful research infrastructure, a population laboratory, or like a square kilometer array, not aimed at space, but aimed at investigating and intervening to improve the health and well-being of poor and under-resourced populations. From this data, one can, for example, follow population dynamics to see how aspects such as mortality changes over time. And so from this data, for example, we were able to show how life expectancy in South Africa increased following the introduction of antiretroviral therapies. But we can also look at migration dynamics, very important for triangulating data from the Statistics South Africa that is available at the national level. Because we do a verbal autopsy on every death that's recorded, we can look at cause-specific mortality and calculate the burden of disease and see how different diseases are contributing to the burden of disease in the country. We can also look at really very important policy measures such as universal health coverage. And because we record everyone in the population, we can also look at those individuals that do not link to care for a specific intervention. Whereas if you would look at facility-based data, you will not be able to see who those individuals are. And so are able then to provide information to policymakers to better target these interventions to people that are not linking to care. By looking at other aspects, we can look at the determinants of disease and social outcomes for social interventions, for example. And so doing, measure the policy impact of different government and local policies. Finally, because this data is geographically defined and spatially located, we can also look in combination with environmental monitoring at climate change impact currently and in the future. The longitudinal data we collect are integrated around unique individual household and homestead identifiers into a complex longitudinal relational databases. It is not practical to do statistical and data analysis directly on these databases, and it's necessary to produce data sets that are more amenable to processing but still maintain their essential longitudinal temporal characteristics that enable causal inferences to be made. The approach is basically to take the episode data stored in the relation database that represent the states, such as being resident at a particular location or being the member of a household for a defined period of time, and combine those with status observations, such as marital, educational, employment, or diagnostic information, for example, HIV status. So if we look at this example record, we have someone that moved from one location to another in the surveillance area through what we call internal migration, and then at a certain point out-migrated, were no longer resident, but then later on returned. So this pattern of cyclical migration we actually see often in our rural populations. But at the same time, this person was a member of a household up to that point where they internally migrates. Let's say, for example, this is a woman that got married and now joined her own household for the duration of the time. And this shows that we continue to monitor individuals, even if they're not physically present, but still retain membership to local households. At the time, marital status, you see here, changed. And we have some regular, but obviously a gap during the time she was away. Employment status changed, and maybe this move was employment related, but when she returned, she was no longer employed. At the same time, we measured HIV status, and after returning from migration, we can see that somewhere during this time, HIV status changed from negative to positive. And what we are trying to do in the processing that I will show you is to integrate this data in a way that allows for analysis. We've learned that the best way to do this is to disaggregate all our data to day level. In other words, integrating our data in such a way that we can reconstruct each day in the life of an individual under observation and record everything we know about that individual at this level of detail. So this episodic data that I showed here, including The status data can then be recorded as a value for every day in the life of this person over the time that the person was under surveillance. What we do then is to aggregate this day-level data back into episodes during which we know all time-varying data remains constant. And so, because there's no change in these days, you see the colored blocks are all the same, they can all be consolidated into a single record, saying that all of those values stayed the same. Here is a change, so there's a new episode. Here's a change again, so there's another episode, and then it changes again for a fourth episode. This type of data can then be analyzed using techniques such as Cox regression. Obviously, this process is very data and processing intensive, and we require the capabilities of the CHPC to do this. As an indication, the 570,000 individuals represents 4.5 million person-years of observation. Breaking this into its constituent days result in more than 1.6 billion records for each time-varying fact that we record for an individual. When we aggregate that back into episodes, we end up with a more manageable analytical data set with around 1 million or so records, depending on the number of time-varying variables included and the frequency with which they change. Still millions rather than billions of records, and manageable to analyze with modern statistical packages, especially if you do it on the CHPC. The setup we use on the NICIS cloud is a single virtual machine running Windows Server 2019 with 25 processors, 256 GB RAM, and 1.2 terabytes of storage. We use SQL Server for the input databases, Pentao, a Java-based graphical data extraction, transformation, and loading ETL tool, and the Julia language for processing-intensive data manipulation. We use the World Bank-developed NADA microdata cataloging tool to curate our research datasets, and these datasets are documented using DDI metadata with assigned digital object identifiers. And this data repository is accessible through the SAPRIN website. The nodes provide us with an anonymized version of their operational databases in a common data model as an SQL Server data pack. We do quality assurance of the submitted databases, looking at data and temporal integrity and plausible population dynamics. This processing is done using Pentao on the CHPC infrastructure. We then use Julia for the dataset production and then share the resulting analytical data sets on the NADA repository on the SAMRC's network. The data set production was originally done using Pentao, but creating the basic analytical data set took more than 6 days running time, and the full set of analytical data sets almost 20 days. For this reason, we switched to Julia, which is more than 3 times faster than Pentao. Julia is an easy-to-use language similar to Python, but as fast as C or Fortran. And we are slowly but surely converting all our analytical work to Julia. Our experience with the NICIS cloud has been superb. It provides a very user-friendly setup, especially if you are not used to a Unix command line interface. The CHPC staff has been very responsive for technical support, and the whole infrastructure has been very reliable for us. Our processing is memory bound, limiting the number of parallel processes we can run at the same time, because long before we run out of processors, we run out of total memory available to us. We can still do more optimization, I think, to make the best use of the infrastructure available to us. And of course, it is not just the processing runtime that counts, but the time that you spend on development and testing. And I think that the setup that we have makes that particularly efficient, and so that overall, even if the runtime is a bit longer, we still save a lot of time using this infrastructure. In future, we are working more on adapting point and time observations to longitudinal data. So for example, to take our education status observation and process that into a complete educational trajectory for an individual over the, in many cases, we have 25 and more years of information about a single individual. So we can really see how individuals progress educationally and, for example, what the factors are that play a role in that. A record linkage to administrative data is a really important future development as well, and it's important for policy evaluation. So, for example, to link the EVDS, the Electronic Vaccine Data System data, to study vaccine coverage and protection correlates. The obstacles here are not really technical, but to have a secure data haven where researchers can have controlled access to such administrative data and incorporate that into their analytical models. In conclusion, I would like to thank the CHPC staff, Dora and Zama, that have been extremely helpful in setting this up for us, the nodal data managers, and of course the Saprin team, without whom this would not have been possible. Thank you very much.
All right, thank you. Thank you, Dr. Kobus. I'll be taking questions if there's any. We've got about 10 minutes for questions. No questions yet. I also don't have a question on my side. Maybe let's give it a few minutes.
Yes, I am here.
Okay, if there are no more questions, we're going to start with the next speaker at 15:45, so that we allow for other people, attendees on other sessions, to not miss this session. So we'll commence again at 15:45. Thank you.
Thanks.
Good afternoon, everyone. Our second speaker for this session would be Dr. David Gwen Evans, who's from casabayo.org. Dr. David has been actively involved in both the conservation and botany for over 20 years. In the last 5 years, his attention has been on the creation of a citizen science platform and NGO, casabayo.org. Dr. David Gwen Evans, welcome, and over to you.
Thanks very much. I'm going to launch straight into the video. It's about 12.5 minutes, bear with me, and then there'll be time for questions afterwards, and yeah. So I hope you can hear it, and I hope you enjoy. I'm David Gwen Evans, and I'm standing in front of one of the last living cedars in this valley. Over the last 2 days, I've been walking through the Cedarberg, and we've been seeing thousands of dead carcasses of cedar trees. Now in the background, this tree has but one living branch, but this tree is in a stream. It's surrounded by boulders, keeping it protected from fire. And this is one of the lucky trees. It's one of the survivors for now. Climate change has been impacting these trees so severely that the only survivors are at the tops of mountains. Over decades, there are photos showing how these trees have been surviving on an increasingly high elevation. And now, when they can't get higher than the top, there's no more survivors. This cedar, Widdringtonia cedarburgensis, after which the entire area is named, is an icon of the area. And not only that, but it's a keystone species, one that is representative of what's happening to the rest of the flora. And this is just one we can see. So the question is, if this is happening on such a drastic level to the cedar trees, what is happening to the rest of the flora? This is something that I, David Gwyn-Evans, as CEO of CHPC.org, have made my mission to find out. In order to know what's happening, CHPC.org is putting together a citizen science platform that aims to provide the answers to the following questions. What is the organism? What does it look like? Where does it occur? And what do we know about it? In a nutshell, a face and a place for every species on Earth. Okay, so welcome to the CHPC interface. I am going to take you through it quickly. So what you will notice is that there are latest observations shown. There's 414 users, 54,000 identifications, 70,000 observations, 100,000 taxa, and 50,000 etymologies, which are the origins of plant names, To take you through the upload process, I'm going to go to observations, upload. We're going to call it Cedarburg November, create collection. I'm then going to select the pictures that I'm interested in and drag and drop them into the dialog, and you'll see those 80 files upload really quickly because we are on the CHPC servers, and there they all are. So it's a very quick connection. We can now do really cool things like rotate the images clockwise or anti-clockwise. We can, for instance, earmark them as dead or alive by clicking edit, tags, dying, stressed, dead, mortality. Yes, so let's click next. And this is now the second stage, the grouping stage, where we, instead of working with pictures, we now want to aggregate them into groups of pictures that represent an observation at a point. So we can auto group, which will set the time to 30 seconds as a maximum between pictures if they are to be within a group. Otherwise, it puts them into different groups. So you'll see it's aggregated some of them. For instance, this one's quite obvious. We can also press I to make it an individual one, or we can select multiple ones and go group, or if they're already in a group, we can, for instance, select those two and click group, and it'll put them in a separate group. So what we actually want, though, is to select everything and I for group as individuals, and we are now done. We can click next and click identify. Now this takes the species name that is in the file and ascribes it to the observation. There you can see it doing its thing, and it's found it for everything. Now that we've done that, we can, for instance, select a picture and go edit, location, and there's our latitude, longitude, and we can type in the locality, which is Cedarburg. There we go. So once we've done all that for all the species, and we can do them all at once by pressing Control A for select all, and then edit, and you'll see now under locality the latitude and longitude is in yellow because it is there are multiple values for it. We can then click next, and we can explore our contributions. So if we go to my contributions, we can see them as a list. There we go, 80 pictures and 80 observations, and we can now view the observations like that. There they are. We can also do the following. Edit view as labels. Now this is quite important because this is how it ties in with the herbarium that I'll show in just a moment, and this is where it generates a QR code which relates to that observation, and we can then go and update that observation. So for instance, say the plant has subsequently died, we can update it. We can view as printable herbarium labels or as a labels table, which we can then export to our label printer for creating labels for bulbs. So let me just show you quickly, explore observations as a map, for instance. And here's our observations in the map. And we can also view species as a field guide. And this is the grand finale in the sense that it aggregates information. So for instance, this tells me that there are, in the family Asteraceae, there are more than 20 species. They haven't been evaluated as the IUCN vulnerability status, so that's the red list, and it gives us an etymology for where aster comes from the ancient Greek word aster, meaning a star, referring to the shape of the flower head. So we believe Casabio to be a truly comprehensive organization based upon the three pillars of Casabio, which are conservation, education, and research, all of which are unified into the Casabio Citizen Science Platform. As an example of this, I would like to point out the digitization of literature. We need representative pictures which are well identified in order to have other people identify pictures using our platform. So to that end, we've gone and digitized nearly every field guide for South African plants, and we have now over, or very close on, 10,000 species which are represented. That is close to half the number of plant species within South Africa, so prodigious. We have also a number of other facilities with a similar thing in mind. For instance, we've got the Adrian Mould Field Herbarium. This was first done the Klein Karoo area many years ago. So let's go and open that up. And you can see here various plants that have been preserved from the Klein Karoo. We also have a big version of that, which is the herbarium. So here's the herbarium over here, and these are all type specimens in red, which are the specimens by which new species are represented. So they're very important collections. We've also got this incredible book collection of botanical and animal related faunal subjects. Or when we get a species from the wild, we need to have it propagated if it doesn't have all the features we need. And that's why we have a propagation unit. And then we need to go ahead and describe the plant if it's a new species. And that's what the microscope is for over here. And then we need to lodge those collections into a herbarium, which is a plant museum for long-term preservation purposes. and so that it can be analyzed in the future. And that's what the herbarium that I've just shown you is for. So that is what makes it a comprehensive, vertically integrated setup, and I believe the first in the world. We are also currently creating the BioSnap app for documenting plants in the field. This is by citizen scientists of all different calibers. So we're making good strides with that, and maybe by the end of Christmas we'll have a trial version out. We've achieved a hell of a lot. These are our milestones and our achievements thus far, but we have a hang of a long way to go. We are still right at the beginning with the desktop platform and the BioSnap app, and due to lack of funding as well as difficulties with developers, we're probably going to need to redo the entire desktop application. But therein lies our opportunity to future-proof it and make it better than ever before. So it's a very exciting thing, and it'll be made to integrate machine learning imagery as well as algorithms. It'll be optimized for those algorithms. I hope that's given you some idea of the CasaBio platform and the NGO, the kind of work we're doing, and also the power and potential of what we're doing. At the moment, it's still a very small organization because of our challenges, but we hope to break free of that and expand greatly as soon as we can. Any questions?
All right, thank you, Dr. David, for that beautiful presentation. We'll now be taking questions. We've got about 10 minutes for questions. Any questions from the attendees?
All good.
Okay, I will just give it a minute.
I think that really speaks volumes about just how good my video was, and that obviously people got the full gist of it.
Yes. Yes.
Well, while the masses think about their questions, yeah, it's been a really incredible system and an incredible process. I've learned a lot in attempting to get it done. Made a lot of mistakes many times. And I seem to be perpetually behind the technology curve. And so every time I'm like, damn it, I'm going to need to get a new developer. The developer comes along and says, you know what, this is old technology. You need this new technology, and then that's implemented. So I think the developers amongst you will be able to relate to that, and people who've attempted to utilize developers. Yeah, it's also been a heck of a, because I'm the CEO and we haven't really been funded properly, it means that I'm having to do everything. I'm the marketer, the fundraiser, the organizer, the guy doing the development. And so I think the main reason why we haven't got funding is just because I'm actually not that good at it, which is an embarrassing thing to admit. But, and so if my thinking is that we need to get someone who's good at it, but then we need to pay them. So that's the challenge I still have to get over. But I'm really excited by the potential of the system. Because it's so efficient already, it's actually the most efficient citizen science platform in the world for uploading imagery and having it organized. And that's been that's been the case now for over a decade, but it's not a mature system. So if we can mature the system, that would make it amazing. But we're also planning to update it radically. So with new technology, it's currently based on a MySQL server, and there are tremendous advantages with our kind of framework to going NoSQL. So that would be a huge advantage. And then the other thing is that we've had JPEG technology for, I think, close on 20 years. But there's new JPEG technology coming out, which will make things more efficient, file sizes smaller, loading quicker, and also integrate well with machine learning, AI. So one can imagine the plethora of applications that conservation can use through utilizing AI. And it's an area that currently all we're really doing is identifying stuff using it, but there's a hell of a lot that citizen science can still do with it. So I'm really excited to be pioneering that within the next few years. Yeah, any questions at this point?
I still don't have any questions. I just wish you all the best on the future.
Thank you very much.
Hopefully next time you come with a presentation, you tell us that there were more funders that you got, and yeah, good luck.
Or maybe I'm just going to get rich myself. We don't know.
You might never know. Yes. All right. I think there are no any questions. So thank you for your beautiful presentation. I think the session will now end.
Thanks very much, and thanks to CSIR and Zintle and you guys at support. I really appreciate it.
Thank you.
Bye.